Welcome to this eLearnSecurity video training lesson on HTTP and HTTPS protocol basics. In this video, we are going to explore the HTTP protocol, performing manual requests, and analyzing the HTTP message exchange between the client and server. In the second part, we'll analyze the HTTP over a secure protocol layer, which is HTTPS. In order to better understand these protocols, and at the same time make our life easier, we'll use a couple of tools. We'll see both command line and GUI-based tools just to be clear on how to analyze and perform communications using these protocols. The first tool we're going to see is Netcat. In Kali Linux, we can run this utility by typing in the console the command netcat, or alternatively the short name, nc. Netcat is a very useful tool that opens a raw connection to a service port. In the following examples, the port will be the 80, which is the official port to communicate with HTTP servers. To study the feature of this tool a little bit more, we can use the argument -h to display the usage. As a goal of this video lesson, what we want to do is to establish a connection to the Ferrari web server and communicate using HTTP. So let's open a TCP connection to www.ferrari.com on the port 80, which is the one used by the HTTP protocol. Let's use the verbose switch to comprehend if the connection has been established correctly with the server. As we can see, the connection to the IP address 54.230.26.84 that resolves to the Ferrari domain has been opened. Let's try to ask the index page. As we can see, the Ferrari web server has replied to our request with the following content. The first part of the message is, as expected, the header section. Then, separated with a blank line, there's the body of the response. Let's analyze the header section. We have as a first line of the response message, the status line. Here, the server is saying that it is okay to talk in HTTP 1.1, and that the resource we asked, that is the index, has been moved temporarily. In a minute, we'll understand why. Then other interesting headers that we have received are content type field that indicates the media type of the entity body, in this case, is an HTML page. The date field that represents the date and time which the message was originated. The location response header field is used to redirect the recipient to a location other than the request URI for completion of the request or identification of a new resource. In this case, the server is telling us that the index page we are looking for has been moved to this path. That's why, in the response status line, we have the 302 code. Other interesting response headers are set cookie fields. These fields are the way the server uses to set cookies within the client's cookie jar. In this case, the server is sending 3 cookies. Finally, there are the 3 headers that start with an X. Usually, headers starting with an X are typically reserved for non-standard usage. In this case, as we can see, there is a proxy server between us and Ferrari's server that is defined within the field via. In this case, the proxy is CloudFront, an Amazon Content Delivery web service. Alright, let's move on to the entity body. Here, as we can see, there's nothing special than a simple message that says to redirect the client to another path. That, of course, is the same one defined within the location header field. Let's try to perform another request to the server, but simply changing the resource to retrieve. Here we go. As we can see, changing the resource, we are able to retrieve the full content of Ferrari's index page. In real life, this is done by the user agent we are using to visit that page. Of course, we can perform further requests to the target server, for example, changing the request method to head. As we can see, the head method returns only the head of the server response and therefore only the header fields. Alright, now let's leave the console for a little bit and let's try to perform our tests in a more user-friendly environment. To do this, let's open Burp Suite from the Kali Linux menu. Then Web Applications, Web Application Proxies, and Burp Suite. If you want a fast way to start this tool, just type Burp Suite within the console and hit Enter. This is what one of the most famous suite of tools looks like. For the purposes of this video, we're going to use the Repeater tool. Here, as you can see, the panel is really simple. We have two views, one for the requests and one for the responses. In each of them, we can analyze the raw content and the hex one. Before starting to perform the HTTP requests, we need to define our target. This is the same operation we did before in Netcat. The host is, as usual, www.ferrari.com, and the port is the 80. Let's hit OK and start forging our request. Burp already provides a starting point. If we want to ask the index page of a target domain, we just have to define the host header and then proceed. Let's try to repeat the same operation we did before within the console. So as host, we define www.ferrari.com and then we hit the Enter key twice. Now we can issue our request to the target server by hitting the Go button. Here we go. The server has replied to our request with this content. As you can see, this is the same one we saw before within the console, but here we have syntax highlighting that helps us better investigate the response. Furthermore, we can select multiple views depending on what we want to see. So for example, the header is organized in a tabular way. Only the HTML part of the response, or also the rendered HTML, which is quite similar to what we would see in a normal browser. Do you remember the location header? Well, in Burp, we can follow the redirection in the current response without manually modifying the request to the target domain. To do this, we have to click the Follow Redirection button at the top of the response view. And magically, on the left view, we have a new GET request and, in the response on the right, there is the official Ferrari website. In addition, we can move forward and backward in our request's history by using these two arrows. As we said at the beginning, the goal of this training video is to analyze both HTTP and HTTPS communications. So, let's complicate our baseline scenario a little bit by moving to analyze an HTTPS website. We'll first start using the console and then using the Burp repeater. For the following tests, our new target will be hack.me. One of the first differences between a connection in HTTP and in HTTPS is the service port. In HTTP, we used the 80, while in HTTPS, the standard assigned port is the 443. So for example, let's try to perform a basic HTTP connection to hack.me using Netcat. As we can see, the server has replied with a moved permanently status message and, as we can see in the location field, there is the path to hack.me over HTTPS. Let's try to connect to HTTPS using Netcat. As we can see, nothing happens. This is because Netcat doesn't do HTTPS connections. Therefore, we cannot use this tool to analyze this kind of communication. Now, if we want to remain within the console, to analyze HTTPS, we can use OpenSSL. The OpenSSL toolkit allows us to operate within various cryptographic functions and, since HTTPS means HTTP over a cryptographic layer, we can use this tool to perform our operations. The first thing we can do is type OpenSSL followed by the command s_client. In this way, we are asking OpenSSL to implement a generic SSL TLS client. Now, to connect to a remote server, we need to provide the connect argument followed by the target information. So host and port is the 443. And here we go. We are now connected to the hack.me server. As you can see, before we can start talking to the server, we need to exchange some information about the certificate used, and then perform a handshake between the client and the server. If you want to analyze this handshake and all the encrypted communications a little bit or in depth, you can use the debug argument. You can also use the state argument to print the state of the handshake. If you don't want all of the client output, just use the quiet argument. Once the connection to the server is established, we can proceed in the same way we did with Netcat. So for example, we can ask the index page of HackMe as follows. Or we can also change the request method and perform other requests. For example, we can use options to ask the server which methods are allowed. So basically, as you can see, the main differences between analyzing an HTTP connection and analyzing an HTTPS connection are within the SSL handshake that is only done at the beginning of the session. So, in the same session, we can generate traffic without performing the handshake each time, while if we close the connection, we need to perform the handshake again and save the new session keys. Of course, there is an encryption part that we didn't see in the previous example, but using the debug arguments can be a good way to analyze this one also. What about the user-friendly version of analyzing HTTPS communications? In Burp Repeater, playing with HTTPS is straightforward, just like HTTP. All we have to do is to select the flag, use HTTPS during the target configuration, and Burp will do the dirty job for us. As we can see, there's no SSL handshake, encryption, and stuff like that. We can focus on analyzing the requests without worrying how to establish a connection between us and the server. And this concludes the video lesson on HTTP and HTTPS protocol basics. Thanks very much for joining us.